Second part of Target 20. We are looking at graphing square root and cube root functions. First part of Target 20 was on square root functions. Today the focus will be on cube root functions. So let's take a look at the parent function of a cube root. This most basic cube root function is g of x equals the cube root of x. And if you take a look at what it looks like, you've got kind of a stretched out S curve here. Okay, that has a center. Okay, and the reason we say that it has a center is because that if we rotated it around that point, okay, that point stays in the center, okay, as we rotate that graph. Okay, so we can rotate it 180 degrees, it comes back in exactly the same spot. Right, rotate it again 180 degrees, right, it's right back in the same spot. Okay, so we call it the center of the graph because it's the center of the rotational symmetry. Now, as you can see, there's 3 points highlighted on this graph. The first is that center point, okay, and then you have one to the right of that center point and one to the left of that center point. It's those 3 points that we're going to be focusing on as we graph cube root functions because they'll always be related in the same way. Now, domain and range for cube root functions is much easier than it was for square root functions. Domain and range for a cube root are always going to be all real numbers, no matter what h, k, and a are. Okay, that domain and range will always be all real numbers. So, if I ask you for the domain and range of a cube root function, I'm basically giving you some easy points because that's always the same answer. It's always all real numbers. All right, so let's get into some examples. Or first, the steps for graphing a general cube root function. Okay, of the form y equals a times the cube root of x minus h plus k. So we start in the same way that we started with square root functions. We want to graph the point hk. Second, we're going to graph two other points this time. We're going to graph the points h plus 1, k plus a, and then h minus 1 and k minus a. Right? Once we have those 3 points graphed, okay, then we're going to draw that kind of that stretched out S curve, okay, through the 3 points, okay, similar to what the parent function has. Right? And as I said, domain and range are always going to be negative infinity to positive infinity, okay, which is the same thing as saying all real numbers. So, plot that hk, right, that's going to be the center point. Okay, then we go 1 to the right of h plus 1, and up k, or up a, I'm sorry. So it'll be h plus 1 and k plus a. Then you go 1 to the left and down a. So that point will be h plus 1, k minus a. Right? You have those 3 points, and then you draw that stretched out S curve. Okay, and every cube root function is going to have that same basic shape. All right, examples. First one, we want to graph y equals 3 times the cube root of x plus 4 minus 1, and then state the domain and range. So getting started, our first step, before we get into our steps, we probably want to identify what a, h, and k are. So a is right here. It's always the number multiplied by the root. So a is 3. H, again, is the number subtracted from x. So this is going to be x minus negative 4. Okay, that's the only way that we can get a positive number in there. So h is negative 4, and k is here. It's negative 1. So step 1 then is to plot hk, which is negative 4, negative 1. So this time we're going to go 4 left and down 1. There's your hk. Then we want to plot 2 other points. So we're going to plot h plus 1, so that would be negative 3, and k plus a, so negative 1 plus 3 is 2. And then we're also going to plot h minus 1, which would put us at negative 5, and k minus a, which would put us at negative 4. So plotting those 2 points, negative 3, 2 is going to be here, and negative 5, negative 4 would be down here. So then we draw that S curve, and again, when we have those higher values of A, okay, it's going to be more of a vertically stretched graph. So you're going to see more of a stretched out S this time. So it should look something like this. And there's your cube root graph. Now, last, the domain and range. Again, should be an easy question. It's always negative infinity to positive infinity for both the domain and the range. Okay, moving on to another example. Why don't you give this one a try first? Pause the video. Once you're finished, you can unpause and see if you've got the correct graph. So first thing I'm going to do is identify A, H, and K. So A is 2. H is the number being subtracted, so that's 4. And there is nothing being added at the end, okay, outside of the root, so K is 0. So step 1, we're going to plot 4, 0, HK. So that will be right here. Second step, we're going to plot 2 other points. So the first is going to be H plus 1, so that'll be 5, and K plus A, so that'll be 0 plus 2 is 2. And the other point that I'm going to plot is going to be H minus 1, which would be 3, and K minus A, which would be negative 2. So we plot those 2 points. 5, 2 is going to be here. Okay, 3, negative 2 is going to be here. And then we draw our S curve. So it comes down like this. And there's your graph. So the last piece then is write the domain and range, which again is very trivial because it's always the same. It's negative infinity to infinity. All right, one more example. Okay, again, why don't you pause the video and take a try at this one. See if you can, what you come up with for the graph, and then unpause and I'll show you how to do it. All right, in this case, this negative symbol means there's a negative 1 being multiplied by that root. So A is going to be negative 1. H, again, because this is positive, this has to be x minus negative 2. So H is negative 2. And then K is negative 3. So our first step is to plot HK. So negative 2, negative 3 is going to be right here. Then, second step, we want to plot H plus 1, so that'll be negative 1, and K plus A, so negative 3 plus negative 1 is negative 4. And we also want to plot H minus 1, so negative 2 minus 1 is negative 3, and K minus A, so negative 3 minus negative 1 would be negative 2. So plotting those points, negative 1, negative 4 is right here, and negative 3, negative 2 would be right here. So when we have that negative value for a, what's happening is our s is being flipped. So now it's going to look like this. And we have kind of a backwards s, right? Got flipped over. Okay, and then finally the domain and range, again, will be negative infinity to infinity. Again, it's a trivial question, but make sure you read the question. If it says to state the domain and range, then we don't want to forget that, okay, as though that should be an easy question to answer. All right, so cube root functions. Okay, you have a center point. Okay, that's going to be the center of the rotational symmetry. Okay, you've got two other points, one on each side of that center. Okay, one to the right, one to the left. Okay, you're going to add a to get the point on the right. You're going to subtract a from k to get the point on the left. Domain and range, always all real numbers. All right, and that'll wrap it up for target 20. Okay, we just have one more target left in this unit on solving radical equations. So look for that in a couple days.